All right, let's go ahead and get started. Before I do, just want to make sure, since it's the first day, Math 242. Okay, so yeah, linear algebra, just want to make sure you're all in the place you think you're in. So a little bit about, so I'll talk a little bit about myself and the class and kind of how things are going to go before we jump into first couple of sections today. First of all, my name is Stephen Reese. I'm a PhD candidate here. It's my fifth year. Planning to graduate sometime the next semester. I have not taught this class before, but I've taught many different calculus, differential equations classes, all of which involve some kind of linear algebra. So even though I've not taught this specific class, I've probably taught everything in it, just in some other package. While I'm talking here, like no matter something I'll remind you of often, if you have questions, stop me. We got plenty of time to kind of clear up anything I need to clear up. Just feel free to stop me, raise your hand, speak up, whatever. I'll get your questions answered. So it's a pretty short class, right? So I think 6 weeks, including finals week. So yeah, I want to go over at least the parts of the syllabus that are, specific to us. If you haven't already seen the syllabus, it's on my Canvas. It's on, I believe I uploaded it to my ASU, so hopefully you can find it there now. I'm sure most of you noticed that we didn't have a classroom until like 36 hours ago. So I was trying to figure out what my office hours were going to be before then, but as far as I can tell, this room is not used by anyone else this summer. So what that means is I will typically be in here early. If you want to show up and use the room, you don't need me to be in here. Show up as early as you want. If I'm here early, we can talk about whatever you want to talk about. For now, like my official office hours are going to be Monday, Thursday, 2:15 to 3:15. I don't want to promise you anything, but on most days, I'm not going to have to like really get out of here urgently. So if there are things you need to talk about, stick around after class and we'll get it figured out. But the days I'm committing to absolutely being here for at least an hour after class are Mondays and Thursdays. Make sense? All right. Textbook, I believe, so it's a custom book written by one of the faculty here. So I don't know if there are ways to get it that aren't the bookstore. But that Linear Algebra Without Theory by Christopher Heckman, please pick that up if you haven't already. Is anyone not able to access Canvas for any reason? Okay, so yeah, I recommend checking that at least once a day, especially for a class that's like kind of compressed into half the time. But I'll be posting announcements, written homework or homework assignments there on pretty much a daily basis. There's already a couple things there now. Get a hold of me for any reason. So I need to emphasize this a bit more. Yeah, email is the best way to get a hold of me after hours. I will get back to you usually very soon. I mean, the only time where it might be a little slow is on the weekends, but yeah, I'm checking email pretty regularly, even after hours. So please, if you need anything related to class or otherwise, please reach out to me, and we'll get it figured out. No matter when I have my office hours, I'm sure they're not going to work for somebody in here. So if they don't work for you, we can still make an appointment. So if you're okay with meeting over Zoom online, we can definitely do that. If you want to try to arrange to kind of meet here before class, we can do that. But if you can't make my office hours, I'll still get help for you. As far as I know, the only tutoring center open right now is the one just outside Wexler Hall on the first floor. I could be wrong about that, but that one I know for sure is open this summer from 9 to like 6, I think, Monday through Thursday. Already something out of date on here. So what am I going to expect of you? So there's not going to be written homework for this class. So I was talking to the coordinator and basically just with as quickly as things move here, we're just going to stick with the online homework. So if you haven't already accessed it, everything, all the homework is going to be delivered through Edfinity. I think there's 1 or 2 assignments that are live for you now that are due sometime next week. So go check that out. I got to modify this. There's no written homework. So basically your homework grade will be 25% all told. There will be 2 tests other than the final. The final exam is set in stone. So August 12th, that's the last day that this class is scheduled to meet. We'll have the final exam, during this time from 1 to 2:10. The midterms, those could move a little bit. So the first one's going to cover the first 3 chapters that we're going to cover. The second test will cover chapters 4 and 5. Right now I'm guessing it basically when we'll end up finishing those chapters. So those could move a little bit, but hopefully not too much. So I'd rather cover the things I'm going to tell you I'm going to cover than really aim at those dates. How are we doing so far? Go ahead.
In person.
All in person. Yep. But yeah, so yeah, we'll do everything in person. You'll notice right now I'm recording. I just use Zoom because it's the easiest way for me to record my classes. So if you can't be here, I'll post the recordings each day. But I'm typically not going to have people calling into this. It's just if you miss it, the recordings will be for you. If you want to go back and revisit something, go consult these. But I maintain a YouTube channel where all these are. I'll post these as quickly as I can each day. Edfinity, I'm going to admit to you right now, this is my first semester using Edfinity. So I believe I know how it works, but you might have to tell me if you're not seeing a homework assignment or a due date or something that I think you should be seeing, let me know and I'll work on fixing it. Has anyone looked at the first homework assignment or 2 yet? You're able to see it? Okay, cool. If you haven't, no big deal, no rush. One of them is like a short review of kind of the basics with matrices. The other one I've posted is the first section of the text that we'll get into today. And then basically I'll just kind of populate those as we cover them. I didn't think that adding them all before class started was a good idea. I didn't want to overwhelm anybody. Grading scales, pretty standard 9-point scale. These are minimums. So these could be adjusted a little bit, but they will never be adjusted more strictly. If I adjust them, it'll be, they'll be relaxed. If you all get 97s, you all get A+. So yeah, if they do get adjusted, it'll be adjusted in your favor. Math tutoring center. So not 9 to 6, 10 to 6:30. Unless it's Friday, 10 to 3. I mean, I know during the fall and spring, there are a ton of tutoring centers open. As far as I can tell, that's the only one that's open during the summer. But it's also well staffed. Anybody in there should be able to help you with what we're doing. If you find that's not the case, please reach out to me and we'll get you squared away. Ed discussion. I've had success with this in the past. Basically what I use this for is, it's inevitable that I'm going to get questions about homework, things like that. But what happens more often than not is if somebody has a question about this thing, I'll get the same question numerous times. Because that I think it's better for all of us if you have a question related to a specific section, question, homework problem, whatever, go to Canvas and navigate to Ed discussion and put the question there. There's a lot of you, I think 32 by last count. So you should hopefully you'll get a response from somebody else in the class. I always think it's worthwhile if you're all learning this, you're all freshly learning this. If you can kind of get someone's input who's also kind of new to this, that's a good place to start. If you ask a question and no one chimes in, I will monitor this thing. Your question will get answered by someone. But from my experience, no matter what the class is, whatever questions people have are usually common to other people in the class. Has anyone used Ed discussion before? Okay. So, is my Canvas up right now? So if you go to Canvas and scroll down, or no, it's right there. So one of the links on the left there is Ed Discussion. Another one is Edfinity. If you haven't used Edfinity before, I think there's a one-time registration charge for $35. Yours will not look like this. Yeah, this is how it looks for instructors, but yeah, so if you've already paid for it, you don't pay for it again. But then just add my class, and as I populate it with homework assignments, you should see them in real time. So the first couple due dates are, I believe they're this coming Sunday and Monday. Yep. Another thing you have to do right now is basically just this quick survey, kind of just let me know like a little bit about you, like if there are things you support you think you might need from me, ways you learn best, whatever things you want to ask me, anything you want. But yeah, quick survey. Shouldn't take you more than 10 minutes, full credit if you just do it. And then I always respond to those, and I'll let you know when I do. Questions so far? Go ahead. Which one? This one? Is it not? That ain't right. Getting acquainted. So when you look, do you have a module that says start here?
I didn't see.
You know why? This thing right here?
There's no promotion.
Go refresh. Okay, I did everything except for publish the whole module. I published the things in it, but not the package. All right, cool. So you should be able to see it now, or in the delay time it takes to propagate to you. Anything else on the syllabus that I should really go over? So we have, I don't think I covered this, but recommend you have a graphing calculator. I'm not going to use the graphical capabilities so much, but usually it's the graphing calculators that have all the capabilities to do matrix operations. TI-83s and 84s, I know, handle matrices really easily. Even if you have one of the older ones, like an 85 or 86, if they're still around. But any TI graphing calculator should do it. The Casio graphing calculators, you're totally fine to use them. I probably won't be able to help you much with those. I'm really well versed in the TI calculators, but not the Casio ones. I will warn you that the first midterm is no calculator. So basically everything we do kind of at the start of class, the first half of class, it's great to use a calculator to kind of check what you're doing, but be able to do those things manually. While I'm on that subject, talk about AI for a second, ChatGPT, things like it. I promise you that anything I ask you to do, ChatGPT can do for you flawlessly. Not flawlessly, it makes mistakes sometimes. My only warning is this: like, if you do something on Infinity that you just ask ChatGPT to do for you, I'll have no way of ever knowing that. But at some point, you're going to have to kind of verify to me without resources that you know how to do these things. So ChatGPT is a great tool for like kind of double checking you, explaining things to you, that kind of stuff. Abusing it looks like just making it do all your stuff for you and just passing it off as your own. You'll probably get a really high homework score from me, but then I don't think you'll be very successful in the class. So that's my only warning. Like, I'm not going to try to figure out who's overusing it, but really it kind of comes to your own detriment if you're using it too much. So, I mean, I admit I use it to kind of like double check myself, but don't pass it off as your own. Questions? Go ahead. Yeah. So if I didn't say that, I'm sorry. I need to update this thing, but basically, let's do it now. Okay. This is not correct. So yeah, just these three categories of things. So yeah, 25% for homework, 22-ish% for each of the tests, and then 30% for the final.
And then, like, is that-
Yeah.
Some people are opposite.
Yeah, so on that second midterm, I'm fine if you have a graphing calculator. The only thing that I'm going to kind of forbid is any calculator that has like a CAS, algebra system. So anything that you can like theoretically just give it an equation and it'll throw a solution back at you. It's a little too sophisticated. You're kind of delving into you're kind of outsourcing your work to AI, or at least a very simple version of it at that point. So if you have a graphing calculator, a good TI-89 or TI-83, I think TI Inspires are generally fine. I don't think all of them have that capability. But without that capability, you still have to know like the structure of the thing you're setting up. So using them is not, you can't use it to produce anything that you don't already know how to do. You're just using it to essentially save time. Anything else? Yeah, Infinity, like I said, I believe it works the way that I want it to, but if I'm wrong, please reach out and I'll get it debugged. All of this is subject to change. So, I mean, I'm kind of taking some educated guesses on when I'll hit certain concepts here. I could either go faster than this, slower than this, but yeah, I'm going to try to get all this content, but if we don't, we'll cover as well as we can the things we have time to get to. And then as we get closer to that first test, so I mean, by the middle of next week at the very latest, I'll be able to tell you if July 14th is actually a good day to aim for. And if not, then I'll tell you what we're going to move it to. What else? The rest is pretty standard. I mean, I'm not going to take attendance, but if you're not here, it's not going to go all that well for you. So everything we're going to do is learnable, but you got to be here. I understand things happen. People get sick. Things come up. Let me know if those things are going to happen. I'll post like I said, I'll post the videos on a regular basis. But it doesn't replace being here. If you have to make up a test, I mean, generally that's a difficult thing to do, especially if you don't tell me in advance. That's even more difficult when you only have 6 weeks to play with. So if something comes up and it's at all possible, let me know as soon as possible that you're going to need to take it on a different day or whatever. I can make those things happen, but they do require some planning. So I got this language in here about ChatGPT. It's not permitted for any work in this class. I'll admit to you right now, I'll have no way of proving it, but just be warned that it can kind of give you a false sense of security. I think that's it. I think that's everything that I wanted to talk about from the syllabus. Any last minute questions about kind of just the way class is going to go? All right, so the way that I'm going to try to structure my Canvas now that have I published everything that I think I have? Okay, so basically I'm going to set up a module in here for each week. I'll have slides that I'll kind of use to guide me through what I'm going to do. Those will be up here. The Zoom videos will be up here. Any of the Edfinity assignments, this header doesn't need to be here. But basically, I will update this every day, at least every day that I actually see it. So if you have questions, if you feel like you're missing something, check here first. Should we do some math? Let's go. All right. So first section we're going to talk about is this idea of Gaussian elimination, back substitution. So I mean, linear algebra, we're going to be doing a ton of stuff with matrices. So there's a lot of things you can do with them. So let's kind of, one thing I want to emphasize is that it's probably something you haven't done a lot of, or maybe any of, but it's all kind of grounded in things that I know you've done. So if we look at this equation here, you could probably think of multiple ways to solve this. So what are some approaches you could take to solve this? Isolate the y. Okay. In which equation? Okay. So if you solve for y, what would you do if you're able to solve for that y, what would you do? Okay. So basically get an expression for y, plug it in here. I usually hear that called substitution. So that's, yeah, totally, I would venture to say it's probably the first way you ever learned to solve systems of equation like this. But not the only one. What else have you seen? Elimination, how does that work? If I multiply the first equation by 5, what does that do? So 10x minus 10y equals 0. I'll just rewrite the second equation, 5x minus 5y. It'd help if I knew how to multiply this correctly. Equals -5. All right. And then what do you want to do with them? If you subtract straight down, you get, from these two equations that have two variables in them, if I subtract straight down, I get 5x equals 5, right? Okay. So elimination is another method. Anything else? Good. So yeah, that's the thing we're going to focus on. So what kind of matrix approaches have you taken? Because even there, like, I feel like I could think of a few different ways to use matrices to get this done. So yeah, one of the things I was curious about is what have you already seen? What things do you already like? What things have people already seen how to do with matrices involving systems like this?
I don't know what it's called, but it's like you put the 2x and the -y, 5x and the -5y, put it in a 2 by 2.
Yep.
And then to the negative first power.
Okay.
And then multiply a 2 by 1 up to 0.
Okay. So you're saying that works. That if I multiply these together, I'll get an answer.
I think so.
Why does that work? Yeah, I'll tell you right now, it absolutely works. Okay. But do we remember why that works? Do we know why that's a valid approach to take? Okay, so we'll cover that later on. But that is absolutely something we do. Linear algebra, much of linear algebra is different versions of solving this problem. Matrix A times vector X equal vector B. You've been solving for X probably since you were 13 or 14. How do you usually solve for X? What if A was not a matrix, but just a regular old number? Divide both sides by A. There's no such thing in matrices called division, but there is a way to basically get rid of that A. So I'm kind of looking forward to the future here by quite a bit, but these are the kinds of things we're going to be doing, is using matrices to basically do a ton of things. They're very, very versatile. So this is one matrix approach. I'm just going to call this A inverse B, because that's really what you gave me. Any other ways that you've seen matrices handle stuff like this? Go ahead. Okay. Okay. And then what do you do with that? Okay. Gotcha. So this right here is called an augmented matrix because basically I took a 2 by 2 matrix and a 2 by 1 vector and condensed them. So this run right here is the one we're going to talk about today. So how do we take a matrix that looks like this and then put it in a form that's actually useful? But this is a 2x2 system. If you did substitution or elimination, how long would that take you? A couple of minutes, maybe. What if I just put one more variable, one more equation on that? It takes quite a bit longer, right? Just even adding one variable really ramps up the complexity if you're going to use those algebraic methods. The good news is when we do matrices, adding those extra variables doesn't really, they're not as significant in terms of like the complexity. So let's take this system that, you know, we've already talked about. We could solve this thing in a bunch of different ways, but let's write it in that last form we just talked about. So this right here. So what was described to us is on the left-hand side of that vertical line, we have a square matrix, a 2x2 matrix that contains all my coefficients. On the right-hand side of that line, we have the constants, basically. What's on the right-hand side of the equal sign? So where does this thing come from? Basically, the middle step I'm not writing down, which I'll write down now, is this. If I take this 2x2 matrix and multiply it by this generic, like that's just the vector I want to solve for, right? I would like to know what x and y are. And that gives me this. So basically, I'm condensing that into this single matrix, this single 2x3 matrix. So first of all, before I go any further with this, any question about how we made that? Okay. So yeah, on the left-hand side, coefficients of the variables, right-hand side, the constants. So the thing that was described to us is we would like to get this to a place where we can start eliminating values, right? Do we know how we can do that? Okay. So when you're dealing with matrices, there are really, I don't know if this is good news or bad news, there are really only three things you're allowed to do. So here they are. So the only operations you're allowed to take when you're operating on matrices, number one, you can swap two rows. Number two, you can scale any row. So basically I can take any one of those rows, just multiply all of its values by the same real number. You can multiply it by 0, but then you've done something kind of not helpful. And the last thing you can do is you can take a multiple of a row, add it to another row, and then replace one of the rows with whatever that result is. I feel very much like the first two are kind of like, they feel like, oh yeah, that feels like I can do that. So third one probably feels cryptic and illegal. For now, I'm going to ask you to take it on faith that it's fine. Then I'll demonstrate to you that we're going to use it and it's still going to get us to where we hope we end up. So these are the three things we're allowed to do. Questions so far? So let's go back to this one here, knowing what we're allowed to do. And let's think about this. What form would I like this matrix to be in for me to like know anything about x and y? So let's think about what this augmented matrix I wrote says. This says basically 2x plus -1y equals 0. 5x minus 5y equals 5. What's my end goal for anytime I have a system of equations? What am I trying to figure out? What x and y are, right? So I would love it if my matrix just told me what x and y were. Let's say x equals a and y equals b. What would the top row of this matrix need to be if x was just simply a? So again, I'll remind you basically, if I translate this from matrix into algebra, what this top row says is 2x minus y equals 0. This bottom row says 5x minus 5y equals 5. But I want this, so that's all good information. I want this matrix to tell me more plainly the things I want. So what would this matrix look like if it was just telling me plainly what x and y equal? Go ahead. 5 and negative 5. Yeah, sorry. Maybe it'd help if we did this. So we talked about like how to solve this thing. Would we agree that x equals 5 based on what we left here? X equals 1 is what it should have said. We agree with that? Okay. If x equals 1, then what does y equal? 2, because we think we said earlier I erased it, but y equals 2x, right? So we know that x equals 1, y equals 2. So let's say in this matrix, where eventually I want to get is to that right-hand column just giving me the answers for x and y. Go ahead. Think about that. 1, 0, 0, 1. If I translate this matrix back into like the way you think about algebraic equations written, what does that top row say? One x plus 0y equals 1. So x equals 1. And the bottom row tells me 0x plus 1y equals 2. So if I can get my matrix system to look like that, then basically I have learned everything I want to learn. So this is a big thing because like this is essentially the goal for solving equations like this. I would like to get basically the square part of this matrix to have this form. Or basically it's just telling me what the variables are. Are we okay with why that is the thing that's desired right now? Okay. So if we're okay with that, how can we make that happen? So I'm going to rewrite this thing at the bottom because this is like our finish line. 1, 0, 0, 1, 1, 2. And we know these are correct. We just checked it. So the three things we're allowed to do. I can change two rows. I can just swap them. I can take any row and multiply it by a real number. Or I can take a row, a multiple of it, add it to a different row, and then just replace one of the rows with whatever that is. And for right now, we're just kind of living with the fact that that third one feels uncomfortable. Okay, so knowing where we're going, trying to get to this left-hand side to look like 1, 0, 0, 1, is there a good thing we can start with? Go ahead. Okay. So, and let's keep good track of what we're doing. So I'm going to multiply row 2 by 1/5, right? If I do that, that's great, but where am I going to put that? I think I'm just going to replace it, right? So that's the operation I'm making. Row 1, I'm just going to rewrite because I didn't do anything with it. Row 2 is going to be what? 1, negative 1, negative 1. Was that a good first step? Was that productive? I think so. All right, what next? Go ahead. Multiply row 2 by negative 1. Why negative 1? Okay, I see. Okay. So let's do this. Let's just condense that into our first step. Let's multiply the second row by negative 1/5. So this becomes negative 1, positive 1, positive. Okay. What else? Go ahead. Okay, I'm going to add row 2 to row 1. Row 2 plus row 1. When I add those together, where am I going to put that result? Back to row 1? Okay. So row 2, I'm going to rewrite because I didn't do anything with it. Well, I mean, I did something with it, but I'm not changing what's already there. What's going to be in the first spot, in the first row? 2 plus minus 1, 1. Negative 1 plus 1, 0. 0 plus 1, 1. We okay with that? Okay. We're actually going to, like, for the purposes right now, we're actually going to stop dealing with the matrix right here. Because even though we didn't get to like this standard, from this matrix that we just wrote down, what do we know? X equals 1. Top row says that, right? System of 2 equations. Once you get one of the solutions, it becomes much simpler to get the other one, right? How can I get the other one? Plug it into what? Right. But does it matter? No. So 2 times 1 minus y equals 0. That yields that y equals 2. So we're kind of taking this hybrid approach right now where we use matrices to kind of manipulate things to a point where we can go back to, something a little more familiar. Any questions here on kind of the approach we took, why it works? Okay. Oh, okay, sorry. Yeah, let's talk about it. Okay, so there are 2 questions, you asked me one question, I feel like you have another one you maybe implied. 1, is it legal? 2, is it useful? As I'm guessing, or should we get after? Okay. I feel very confident in answering the first part. Can I get a blank screen somewhere? Now let me give myself a corner here. So the question here is, why am I able to multiply? Basically, why can I add a multiple of one row to another? So these are my equations: 2x minus y equals 0, 5x minus 5y equals negative 5. Is it legal for me to do this? 6x minus 3y equals 0. Have I changed my system of equations if I do that? No. Right. So what I'm trying to show you is that all that junk we do in one move is made up of things that hopefully you'll accept as okay if I slow it down. So I multiplied the first row by 3, right? Would you agree this is also an equation that satisfies this? 11x minus 8 equals negative 5. Okay. So that is what that third elementary operation is. I take a multiple of that first row, add it to the second row, and then I've got this third equation that doesn't really look like it's similar to these first 2 equations, but it is. So basically that third operation is another way of packaging old information into a new piece of information that's hopefully more useful. This, what I just did, I would call this deeply useless. This 11x minus 8y equals negative 5, I don't think this did anything for me. But the reason that it's legal is because really we're kind of like fast forwarding to the end of 2 processes that you probably do and take for granted all the time. How we doing? Okay, so you're probably feeling like matrix method is overkill for something like this. But what about that? So if you're going to do substitution here, I think the best thing you can hope for is one of the variables equals something having to do with the other two variables. You have to get really lucky for elimination to work. You could probably make one variable eliminate really easily. Let me just fix the hideous mistake that I noticed. So for elimination, you could probably manipulate this in such a way that you can make X, Y, or Z eliminate pretty easily, but you probably wouldn't get a second variable to eliminate with it. The reason elimination works very nicely with two variables is if I always know I can eliminate one, I'm leaving one left. I think you're always gonna leave multiple variables behind. One more thing I want to do because I feel like I didn't budget well for this. And the screens in here are nicer than what Wexler Hall has. Is that still visible for you? Yeah. Or did I? Okay. If anyone can't see it, let me know. I'll put it back. All right. So I want to solve this using a matrix method. What do I got to do first? I got to write a matrix, right? So translating this to a matrix becomes 3, 6, -3, -2, -4, 4, 4, 5, -13, 15, -12, 14. What's the goal we should be kind of heading toward? Like we wrote down what it looks like for a 2x2 matrix or a system of two equations. But what's my goal this time? It's going to be larger. Go ahead.
Like one diagonally from like top left, bottom right.
So 1, 1, 1. And what goes elsewhere? 0 everywhere else. So if I wind up with this, then I think that top row will just tell me, yeah, whatever winds up in this A will be whatever X equals. Y will equal B, Z will equal C. So this is a good like end all be all goal. If I can get to that matrix, then I'll have all my answers. I'll know what X, Y, and Z are. So let's start marching toward that. So from our matrix, what's a good thing to start doing? And again, I don't know if this is good news or bad news. There are like no one way to, in fact, like when you start doing homework problems like this, do it by hand and then ask ChatGPT to do it. It will almost never do it in the same way. There are like many ways to approach this. What do you got?
Well, I don't know.
Oh, go ahead. Okay. So let's translate this thing back to. Let's rewrite this as equations. What would that top row look like if I transformed it into an equation? 1x plus 0y plus 0z equals a. So the only term that survives there is x. So similarly, the only term that survives in the second row is y. And then z. So we'll getting way ahead of myself with this. This matrix right here is called the identity. If you get this identity matrix, basically what this does is it just passes along the first entry of the column that's multiplied by this one passes on the second entry and so on. So if I get that, I can just look at that matrix and see what my solutions are. So now let's start marching toward that. Lots of good ways to start. What do you got?
Is there ever like a wrong first step that you choose?
Yes. But there are lots of right ones. What do you got?
Yeah. Second.
Second row of the first row. How come?
One. MC also big one.
Yeah, so I mean, that's what we have here, right? If you can get a one, we start getting ones along this diagonal. We know that's desirable. So after I add row one and row two, where do you want to put that answer? Back into row one. Okay, doing that gives me, and by the way, when you're like doing your work for stuff, I really recommend writing down what you're doing to get from one to the next. Otherwise, debugging these things gets really hard. So row two, I'm gonna rewrite. -2, -4, 4. Row 3, 4, 5, -13, -12, 14. Now the first row is going to be different now. It's going to look like 1, 2, 1, 3. I feel like that's a good first move. All right, good first step. I got a 1 in this place. I like it. So here's the thing. I would really like to not do anything that ruins that 1. Because as we like add rows together and do stuff, if we alter row 1, I want to alter row 1 in a way that's not going to hurt what the progress I've already made. So right now, I'll admit to you, I'm like speaking kind of nebulously. We'll kind of put more strategy behind this, but go for it. Yeah, I mean, row 2 is full of even numbers. One thing you will probably learn about doing matrix operations is that smaller numbers are more friendly. So if I can scale them down without getting fractions involved. So cut row 2 in half and just leave it where it is. -1, -2, 2, -6, 1, 2, 1, 3, 4, 5, -13, 14. Love it. What now? Go ahead. Row 2 minus row 1. What would row 2 minus row 1 give you? Row 2 plus row 1. Is it okay if we already did that? Totally okay. Yeah, I can do it whenever I can. I can do whatever I want as long as it's one of those 3 things. So I'm going to multiply or add row 1 plus row 2. Where does the answer go? Row 2. Good. You've already done some meaningful stuff with row 1. Want to leave it alone for a while. So 1, 2, 1, 3, 4, 5, -13, 14. What does the middle row look like now? 0, 0, 3. Yeah, 3, -3. Okay, I feel like we got lucky. All right, what now? Go ahead.
We would swap.
Yep. If we swap row 3 and row 2, row 2, row 3. So 1, 2, 1, 3, 4, 5, -13, 14, 0, 0, 3, -3. So close to that bottom row looking the way I want. So let's take care of that. How can I make the bottom row look exactly the way I want? Multiply by a third. So 1/3 of R3 goes right back to R3. Okay, bottom row is nice. Here's what I would love to do, right? I know what Z is, right? So let's say I stop doing matrix stuff here. I can plug in Z for, all these Z's, right? But then I have equations, and I still have two equations with two unknowns, right? So let's go a little deeper with the matrices. I would like to just be able to just substitute in Z, basically substitute in Y, get Z or get Y. Sorry, let me start the whole sentence over. I would love to substitute in Z into this equation to get Y for free, and then plug those back into this one to get X for free. But to do that, I think we need one more zero. So I've made this bottom row look the way I want it. Let me dictate the goal for this next one. Can I put a zero where this 4 is? How would I put a zero where that 4 is? Okay.
It's 4 times.
So something minus 4 R1, row 2 minus 4 R1, and I'll put that back into row 2. And hopefully I left myself enough room to actually do it. Okay, bottom row I never want to touch again. It's perfect. Top row I didn't do anything with. 1, 2, 1, 3. Middle row will be what now? This will never be 0 because that was the whole inspiration for this. Row 2 minus 4 R1, 5 minus 8, negative 3. And then negative 13 minus 4, negative 17. Row 2 minus. Is that okay? Okay, so this feels like a good time to warn you that is multiplying numbers together hard? Is adding them hard? Subtracting them? Those are all very simple things to do, but if I make you do them 3 dozen times, it's not uncommon that you're gonna make a mistake somewhere. So that's one of the big reasons that I really recommend being clear about what did I do from this matrix to make this one. I did this operation. Because it makes searching for those mistakes a little easier. So now can we solve this thing? Can we jump out of the matrix approach here? We know that Z is equal to -1, right? Do we know what Y is equal to, or can we figure that out? How do we do it? Right, so now, basically I'm kind of like letting that Z help me get one more solution at a time. So -3Y equals -15. Okay, now I feel better about that weirdness that happened. Y equals 5. And finally, what's my last move? Find X. So 3 times X plus 6 times 5 minus 3 times negative 1 equals 15. X equals negative 4. This is 3. 15 minus 3 is 12. 12 minus 30 is negative 18. So what did I say? Negative 6. Now I think it's right. So in these, the way we're doing this, we're not getting to that like this like really idealized matrix, but we're getting close to, like, we're approaching it so we can kind of do this hybridized method of matrices and, you know, algebra the way you've always done it. Go ahead. No, I should have done that. I mean, I basically just ignored all the work we did, right? But if I did everything right, then it should be the same. So if I do x plus 2 times 2 plus 1 times z, which is negative 1, equals 3. Oh, what happened? Oh, yeah, y is 5. Thank you. Does this work? 4. Yeah. So the short answer to your question is no. If you do everything right, it does not matter. So it does not matter where you plug it in. So I gave you a system of 3 equations, right? I think we ended up writing a system of, okay, we made a new one here. 4, 5, 6. We just moved things here. So I think in total, we looked at 8 different equations here. They're not all different. Like some of them are just repackaging other information. But in doing this manipulation, we're generating a bunch of new equations. Hopefully some combination of them will be productive. How we doing? Go ahead. You have a question?
Is it wrong to simplify the equation before you pull it?
Absolutely not. So, I mean, from here, what would you have done to start?
I would have put the first equation as x plus 2y minus z equals 5.
Yeah.
And then simplify it.
Right. So, absolutely fine. I mean, I wouldn't even want to guess at how many different ways there are to get from here to here. So, yeah, reducing all these, that one, everything's divisible by 3, everything's even. I don't think anything's going to help you with that one, but lots of ways to start for sure. How we doing? Okay. So here's the form we're kind of marching toward, this upper triangular form. So along this diagonal, which is, we've not done a 5 by 5 matrix, but that's what this kind of entry shows you. This major diagonal. So every matrix has 2 diagonals. The one that goes top left to bottom right is called the major one. We have upper triangular form if everything below that is 0. So once we get that, then we can kind of start doing that serial. All right, I know what z is, or I know what this variable is, and I can use it to get that one. Then I can use these 2 to get that one, and so on. So the title of this chapter is Gaussian Elimination. That's what this process gives you. So basically, Gaussian elimination is the process that takes any matrix and reduces it into this upper triangular form. Or a term I would bet that most of you have heard is row echelon form, which it usually has like this staircase looking form to it. If you've ever done stuff with matrices on your calculator, see REF and RREF. This is what the REF stands for. How we doing? All right. We have time for one more, hopefully. We got two more. I don't know if it makes sense to do both. Let's handle this one. Let's at least start it. I feel like, wait, is it 215 or 210? Oh no, right now it's 2. I'm sorry. Let me answer the question I should have asked you. What time does class end? 2:10. Okay. So let's start. We may not get to the end, but let's see what we do. Right. I believe all strongly you could all do this. So let me get ahead of you. 6, -3, -6. All right. Any ideas? Go ahead. Okay. Row 1, everything's divisible by 3. 1/3 R1. Put it right back. 2, -1, -2. -21. Good. Smaller numbers are easier to handle. So I think that's a good move. What now? Should we remind ourselves what our goal is? So I originally kind of stated it as this idealized matrix. Like the only non-zero quantities you see are ones along the diagonal. But now what I'm really looking for is so how many things in this matrix do I have to turn into zeros? 3, right? I need a 0 there, there, and there. If I get that done, then I can kind of pick it apart. So knowing that that's the mission, what's a good next move? Go ahead. Okay. So row 2 plus 2 of row 3. And where would you like that to go? Row 3. Okay.
Wait, I'm sorry.
Do you want to go to row 2? Okay. Good news is neither one of those is wrong. It'll probably change the way in which we get the solutions, but it should not hurt us. So row 1 is the same. 2, -1, -2, -21. Row 3 is the same. All right. So this middle row is going to be what? What's the first entry? I believe that was the whole point of why you chose that. So we're good. Row 2 plus 2 of row 3, -7. 3. And 47. Double check me. I feel good about it, but I'm flawed. Okay, we got a 0 in one of the places we wanted it. Now what? And I get a 0 on one of the two bottom row slots that I wanted in. Go ahead. Three of row 3 to row 2. And then where would you put that answer? That's not terrible. Yeah. So it gets a 0 somewhere else, but let's get these 3 first. Two of row 1. 2 of row 1 plus row 3. 2 of row. What are you trying? What's your goal?
Trying to get a -2 of row 3.
You're very close. You said add them together.
Yeah.
And you gotta make one little tweak, but you're very, very close.
I would swap, row.
So I want to take this last suggestion because it was very close. I think you said to add 2 of these to this. Is that right? Well, the adding doesn't matter which way you go, but if you want to make this a 0, I think there has to be a subtraction, right? So let's modify that a little bit. I think if I do row 3 minus 2R1, which is very close to what you told me. And then let's put that back where? Row 3. So 2, -1, -2, -21. 0, 7, 3, 47. And then row 3 minus 2 of row 1, -5. 0. 3. 15. Go ahead.
So
Go ahead.
zeros, all of you could have 2 separate zeros, row 2, 1 in row 3, and still the rest of the variation.
Yeah, so if you have that, then essentially you can swap rows around and make it triangular. So, but it's so you are right that those are equivalent because you can swap rows. So where do we go from here? So our last goal is to make this -5 a 0, right? Can we do that? Go ahead. Right. So I will tell you right now, I believe that that is unavoidable. So this is, I will admit to you now, this is a trap I set for y'all. I have not warned you that it's really in our best interest to move from left to right. Because, yeah, putting a 0 right here, yeah, there's no way to make this a 0 without this popping back up to something non-zero. So let's do this. I got 209. Let's stop here and we'll revisit this. But let's talk about, like, I will tell you right now, there are foolproof ways to go through this without ever having to revisit these zeros. So I wanted to focus on the elementary row operations. We'll layer some strategy underneath it tomorrow.